Hello everyone, welcome to another stream. How's it going? Welcome, welcome, welcome. So this stream we're going to do a bit of a recap on the entity system we've made. So I'm just going to get some notes together and then we'll be underway with that. And if we get enough time, we might start designing moving on to the next task, which is the decoding and encoding system, so serialization. So we might get started on this today if we are well enough. Hey Gloria sir, sorry to fit you in the last stream, got distracted over things home. No worries. Not doing bad, not doing bad. Thank you. I recently bought this camera, got this Anchor one, but it looks really good because I tested it out on my work PC. Gave it a spin. 4K, but it does 1080p and 60 FPS. And it didn't work on Linux. But I'm going to try it again one more time. I might have got it on the wrong USB port, maybe. Maybe it's not got enough power or something. So I'm going to try another one out. But yeah, other than that, it's been really busy. Yeah, just been super busy. So, yeah. But yeah, that was a really good find earlier when you found the stuff with the Vulkan API. That could very well be the cause of my issues I've been having. I wonder if I've got the configurator on here. Have I got the configurator? I know it's installed in the Windows SDK. I think I have to install it separately in the package manager, so it's not too bad. So I got some notes that I want to jot down some things that I want to remember to talk about. So I want to remember. Right, so we couldn't quite achieve the unified API for AOS and SOA. So instead we'll just instead we'll just write the same logic again. Well, we did kind of achieve it actually. We did, partly unified API for AOS, everything but the iterator. I think, yeah. So that's okay. So instead we'll just, write specific code if deft out to compare to benchmark and AOS versus SOA implementation. So that's something that we didn't quite achieve from the last one that I would like to talk about. There's another thing. Optional fields. Optional fields are not inside the entity system. They're just they're done manually instead. So those are things I will bring up. In time. So how do I want to structure this video, so I can talk about so I can first show off the entity system. So I can just show off, that it works to some degree. The rendering is glitchy, yay, but it's got those regions, and it has this sort of person that goes up and down between the regions. And maybe I can get the numbers printing out again to show that the person does move. Yeah, so I might recap that one. I guess just start there. Game Stylist, hey, how you doing? Welcome to the stream, sir. How's your day going? Oh yeah, I got the buttons on here. Am I making an engine or a game? Well, I guess I'm doing both. So making a game without an engine, so it's really an engine that's designed for this game. You know. So I'm not writing a bunch of systems that I won't need for my game. I'm just writing ones that I need for this game. I'll probably over-engineer some things. That's a very hard habit to kill, but yeah. Vulkan, VK. Yeah, we're just using compute shaders. Doing ray tracing in compute. Looks lovely, thank you. Yeah, looks good. Especially with this cube map background, which I did not render as a photo. Yeah. It's a nice photo that I can just look around. But yeah, besides all the glitches, at least we got a, I don't know what this is. It's not even that big of a map, and it's super glitchy, but it's cool. We're not building maps right now. I want to build like models, so this will do for now. What stack you use? Uh, the operating system, Windows, Linux, basically, and Vulkan. So everything's written from scratch, basically. Everything you see here is, except for interfacing with the operating system and the C compiler for the CPU is handwritten. We also wrote a C compiler for the GPU, so I use C as a shading language as well. So yeah, that's the stack that we use. So I've got. Oh, that is not confusing. There's a VOD channel where it goes over everything in the past. No, I just told you. We don't use an engine. So here's our dependencies folder. Just like STB libraries, some stack trace library, and then my custom C compiler for compiling to GPU. And then I've just got the whole engine is just written in here, GPU layer, core layer for custom allocation, UI, operating system. So it's all just, yeah, from scratch, basically. Yeah, custom C compiler. So that's only for shaders. So I can write I got a file which gets compiled in my compiler, and it does compute shaders, pixel shaders, vertex shaders, but I'm only using compute shaders for this project, and this compiles to the GPU. Yeah, it's quite nice. I have it so I can share code and data structures between the CPU and GPU, and I've got a maths library which works across CPU and GPU as well. So it's pretty nice. There's the link. Oh, I already linked it. But yeah, so here it is. It's got some restrictions, right? You can't have everything work on GPU because the GPU vendors want to keep the nice things away from people. Yeah. Oh wait, sorry. These are the features. These are the limitations. It's a bit bigger. Yeah, that's right, Cranston. Cranston's got it. How's it going, Cranston? Welcome. Right. Let's do one of these. Hey. There we go. Lovely. Lovely. Hello everyone, welcome to another devlog. So in this devlog we're going to go over this entity system that I've built and just recap how it's put together, some of the things that we achieved, some things we did not achieve, and I could do a better one. Hey yo, I'm fiddling with some hardware for once, quite fun. Awesome, what sort of hardware? It's like a mini board or something? Like a microcontroller? No, I don't support Mac because I don't have a Mac. Yeah, I thought about buying a few times buying a Mac laptop before I got this Lenovo, but I couldn't convince myself to spend over £1,000. So I spent £200 and bought an old laptop. I went and cheaped it. So, because then I would have thought I would have had to have ported it to Mac, and then I would have to live in Mac as well. Where I do quite like working in Linux over Mac though, but Mac is a good second option, I think. Right. Yeah, I don't know about them. Yeah, also like the ecosystem definitely is. It was definitely getting like the iOSification, right? It became more and more like a phone in a way, and there are restrictions in that and are coming into. So it's probably really. You can obviously run your own applications that you compile, but yeah, yeah, the next code, it's probably stuff like that you have to do. Apparently, some of the tools are quite good, but quite like using Linux, you know. Hello everyone, welcome to another devlog. So we're going to be looking at this entity system that I've put together, and I'm going to go over like some of the things from the last video and that we couldn't quite achieve, or some things that we have achieved that were not mentioned in the previous plan video from last time. So in front of us what we're seeing is a grid of tiles. So these are these sort of like ellipsoids here. I think it's like an 8 by 8 set of 8 by 8 set of ellipsoids, and there's a grid of them that fill out this sort of floor. The rendering is a bit glitchy, but excuse. So those are all an entity. Each tile is an entity in the entity system. And then we've also got these sort of player entities over here. There's two of them there. And there's this one here which is moving between these regions. These white boxes, if you will, are different regions. And the regions are going to be bigger in the actual game, but I'm testing the entity system on a smaller scale right now. And then there's this box that appears and disappears, and it basically tests blocking this entity from moving, and also spawning something and destroying something, even whilst this thing could be moving in its way. Cool. So something to remember from, just keep doing these sows, and then I basically just have within a minute I've said like 50 sows. Within, why is it within? Why is it within? As you saw in the last video, we had these regions where in each region all of the entities were contiguous in memory, and we still kept that. Actually, do I want to put this in here? Right. Bum 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 bum. Let's open up a new window. Source. Logic. Right, this is good. So we did end up going the code generation route, as we mentioned in the last video. So in my scripts folder, which is at the root of my project, we have 2 new files. We have 3 really, one for each platform, I guess. We have the entity code generator, which is written in C, which you'll see in a bit. And we have 2 shell scripts, one for Windows and one for Linux, which basically just compiles it and then runs it right away. And it will generate our code. And then inside the source directory, logic, and entity, we have a bunch of files in here. These are the 2 files that the code generator will kick out, which is with a sort of a suffix of underscore generated. So this is so we can remember not to edit these files and actually instead just edit this entity layout file and then just rerun the code generator, and only these files will change, right? And then these 2 entity.c and entity.h are simply just all the stuff that does not need to be code generated, and it includes these files which have been generated in the right places. So we'll see more about that in a moment. Cool. Yeah, you could use C++, Glad, and GLW, but there is a new boy in town. Have you guys seen the SDL3 stuff? It landed the GPU abstraction, so you don't have to use OpenGL anymore. So they got a GPU abstraction that sits on top of Vulkan, Metal, and DirectX and all this. It kind of got released last week though. But I looked at it, it looks good. It looks like a good one for people who are just getting into programming and things. And you know, people run their own engines, indie game engines. Seems pretty alright. Seems pretty good for most 3D stuff and all 2D stuff, for definite. If you're gonna do like proper high-end 3D stuff, probably better to maybe roll your own stuff, but that's very rare for indie stuff. Yeah, it does look good. I like some of the decisions like they've made. It's just quite simple. But yeah, abstracting over that is just crazy. Yeah, GPU APIs. How's it going, Pete? How you doing? Right, so should we put some more things on here? I don't know. No, we'll put on like strength or something like that. Strength, health. Set up in height for some reason. Alright, let's code gen that quickly. Alright. Oh, damn it. Oh, have we got a bug? This ain't good. Put a breakpoint in here. This is not what I want to be doing today. Very much took a look yesterday on stream. Looks like a Vulkan light to me, which is good. Cool. Nothing fancy hardware wise, just arranging the guts of the old PC boxes, grouping components by performance, and adding new cheap secondhand stuff. Cool. Have a NAS offsite backup. That's great. Yeah, I've been looking. Well, I've been considering it a lot because we've got a son now. I'm taking tons of photos, and you do kind of want them backed up somewhere. It's kind of nuts. Pull props. I need to hex that. Good old /x. E. Right, it's the final 3 bits. Yeah, why is it E? What the crap is that? Yeah, what the crap is that? What the living what is going on? Looking for if that property exists. Right, I think we've just done something a little bit silly. Right, I didn't zero the prop not exists thing. But for some reason that's only shown up now. Bit strange. Alright, seems alright. I didn't zero the I think that's what was going on. Uninitialized variables. There we go. Fixed it. Right, that's good. So we've got a little bit more things now to to make them different. Make those entity types different at least. So we can. There we go. Hey, Hostman. Doing good, doing good. Yeah, not bad. It's pretty tired, standard, busy, working hard, spending time with my boy. What's my boy doing? Seems alright, there we go. Yeah, yeah, just, how about you, sir? Hostman, what you been up to? Yeah, when you're in technology yourself, you realize how fragile this stuff can be. Yep, definitely. Like, my wife left her phone in Asda the other day, and I was like, great, there could be some of her pictures gone. So, yeah, definitely one of those things we're considering. But I'm trying to save some money right now. One of them. I might just back them up to this PC for now. Do it over the weekend or something. It's probably a good idea. But at least it's much better than having like an Apple phone or something. I've got an Android phone, so I think it's easier to back up these things. Maybe. I know Apple want you to use their iCloud in it. Hey, Peichi, welcome. Sounds nice. I'm writing my master's thesis. Sounds technical. And doing the last programming assignments for my uni program. Amazing. That's cool. Sounds like you're getting quite up there with that. That's great. How close are you to finishing? And you start like a new year now. Right, I guess we can talk about this. So this is the entity.layout file. Effectively, when we want to make changes to the entities or the properties, we simply just edit this file, rerun the code generator, and all of the changes just take effect, and we should just be able to go on from there. So you notice how we've got two different archetypes for now, because if you remember in the last video, we've got to be careful on the number of archetypes, because per region, all the archetypes are stored linear in memory. So if we don't have many archetypes in a single region, there's not really much benefit. So right now we've got a block archetype, which is like those tiles on the floor that you saw. And then we've got the organism archetype, which is those sort of players that you saw walking on top of the tiles. So we just got a very small thing in here for now, but we can easily extend it. So at the top, you just list your properties. It starts with a prop keyword, and we simply just put in some string, which is the type, and it will just copy and paste that into the file, into the code generated files. And then you put the name of the property, and it'll copy and paste that into the code gen files, obviously. And then you got the archetype, you prefix with the archetype keyword with the name of the archetype, then this colon, and then a comma separated list of the properties. And these names have to match one of these up here. So for now, this is basically it, but I have sort of added something like a swizzle sort of thing. So if you have like a vector, you can kind of get things to be swizzled and things like this. Hey there, Paichi. Thank you so much for that. Really appreciate it, sir. Appreciate the sub. Thank you, thank you. You also get access to the code, by the way, if you didn't know that already. Thank you for supporting me. You can get access to the GitLab, download the code on your machine and give it a run, or peek into the secret sources. Appreciate it, sir. What's up, Spearviers? Very much. How's it going? Doing good, sir. Doing good. How are you? Have you computed your shaders yet? Mm-hmm. Right, I think I'll take that one again. Ovs. So one thing that is kind of hidden is that every archetype has a coordinate. And so that means in the world, there's a 3D grid, right? And it's an integer grid, right? No floats. And we basically have a 3D coordinate property that's built in to every single archetype, since we're always going to want to have an entity that exists on this grid. And we also have another sort of thing where if we have a property which is a vector, we can request it to be swizzled. But I haven't really fully implemented that in the code generation side, just the parser side. But there's many things we can just add like this, which can allow us to generate some different code and with very little expression. Cool. So should I take a glance at the code generator, I think? Or should I go into the code which has been generated? Let's go into the code generator. I learned that there are learned English. You're European. You are European very much. Unless American English here. That are GPUs. There are GPUs with more than one wave size. No. Easy. Easy. Okay. Let me let English. But yeah, but let me tell you. GPU. No worries. Wave 32. It's a bit like burnt, right? You say I burnt the bread, right? You don't go I burned the bread, right? Or another thing that Americans do is they go, whoa, they're headed in that direction. You go, no, whoa, they're heading in that direction, right? Like, it's a complete, like, destruction of the English language. Anyway, I'll move off that sidewalk. So the thing you have to be aware of is that all GPUs support Wave 32, all of them. So when I write code, I always just write code for Wave 32. So what was this? NVIDIA. So NVIDIA's always Wave 32. AMD supports Wave 32 or 64. And when you run it in Vulkan, you have to say, use Wave 32 mode, please. And then it will do it. And then Intel's a funny beast, but they support it too. So AMD, right? Let's just get in there. Features, properties. There we go. So they have a max subgroup size or wave size of 64, but min of 32. So you can select that. All good. Wave 64 is quite nice in some cases, but Wave 32 is just cross-platform. And then you got Intel. Let's find an Intel cards. They got Arc series, but they've also got like old laptops, like this thing here on the side. These guys, this is a funny one. Their min size is 8, and their max size is 32. So what's funny about the Intel ones is if you run in Wave 32 mode, they'll run the same instruction like 4 times because they only have 8 wide SIMD units in the laptop, but they've got the Arc GPUs now. So basically, from your language perspective, you don't have to worry about this. That's the user's problem. Oh wait, you've got that thing, isn't it? Where it's the size of a wave. Yeah, they run the same instruction 4 times. Basically. On a wave 8 thing. Intel Arc. So these are the sort of more recent GPUs, which are actually going the PCI. These ones, are these 8 wide as well? I don't know. No, this is mobile. Right, my mistake. Alright, not the mobile one. Is this a mobile one? I don't know. This is another 8 wide again. Who knows? Are they all 8 wide? Yeah, I guess they're 8 wide as well. It's a bit weird. But yeah. Maybe they support native 32, Wave 32 on the Arc cards. I'm not sure. But I remember actually seeing in a video from the Intel ones about the Wave 8. No, they run the same. So there's like it's a bit like how the GCN ones worked on AMD. So if you got like your shader, right, it's this power instruction. It will run this. Say if you got a wave, you're running in wave 32 mode. It will load the first 8 VGPRs into the ALU, right? Do the arithmetic on 8 of them, and then put it back into the VGPR memory, and then go to the next 8, and then do the same again. So it's able to. So rather than having a 32 wide ALU, is an 8 wide ALU, right? And it does it 4 times. So sequentially. Yeah. And then it'll move on to the next instruction. But that's only when it's in wave 8. So the GCN one, I forget exactly what it was, but I think they had wave 16 ALUs, but then they had supported wave 32 and wave 64, I think. Or they were just wave 64. I forget. Yeah, I think they were wave 64, then they had the 4. Each instruction took 4 cycles because it had to do the 4 ALU bits of the VGPRs. And then they could also do some other things at the same time. Those help hide latency or something. Yeah, I forget these things. So that means I have a subgroup barrier on Intel 1 with it to add some more No, it is lockstep. Yeah, it is lockstep still. What about the Apple ones? No. Not a waste. So the AMD has dual compute unit. It's incredible. AMD hardware is pretty cool. So the AMD hardware, what you have is this thing called a workgroup processor. So it's got 2 compute units in one workgroup processor. These run in wave 32 each, right? They have like a shared LDS memory. They have a shared set of VGPRs, a shared set of SGPRs, right? Scalar general purpose registers. These are my CUs. And basically, if you run in wave 32, these guys can run independently of each other. And they will just run different shaders, and that's all right. But if you run in wave 64 mode, these two become buddies and pals, and they basically execute the same shader, but they run in lockstep at wave 64. So you don't waste anything. So you get the benefit of having less cost for the branches in wave 32 mode on AMD hardware. And yeah, pretty neat. I might keep it. Let's keep it. Are GPUs... do GPUs only have one ALU port? I can imagine if they have 4 ports with... Yeah, I don't... It just really depends on the hardware. Like, AMD just have a 32 wide ALU in each CU. I'm not sure about the Intel one. I think it was modeled after the yeah. So they each of those ports will be a different CU. I think on the Intel one, right? I think because it's like a laptop CPU, kinda. Is this new? No, this is since RDNA. I've got RDNA 2, and I've got an old, like 2 years ago I bought an old, like 2-year-old hardware, so it's like 4 years old now. The RDNA 2. That's like PlayStation 5 technology, I think. So however old that is. I think PS4 was GCN tech. Yeah, so if you look at the RDNA manuals, so your RDNA 2 is what I use, but there's also an RDNA 3 one, instruction set architecture. If you have a look at the 2s and the 3s, you'll be... But yeah, these are really good. They're a really good read. They're a lot of fun. And you can learn all the bits and bobs about them. But sometimes they're a little bit confusing. So they take a bit of like research. But yeah, they do have diagrams as well. There's pictures. We all like a good picture. So this is just another version of what I drew basically. There's your workgroup processor. Here's your CUs, your compute units. Right. Yeah, the VGPRs are here, then the ALUs anyway. But yeah. Because it contradicts the Vulkan source on Kronos page 2018. Huh? What do you mean? What do you mean it contradicts what Vulkan says? What is that? Pretty sure it doesn't? Right, here we go. Let's have a look at this one. Well, what's the thing that it contradicts? What's the thing exactly? Subgroups of n parallel tasks, blah 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 blah. I want to do my Gen Z, skip until I find something interesting. How much the GPU is idle? Yeah. Right. Okay, I know what you're talking about now. Here's the problem. They designed something terrible, and then they had to fix it in the next one. What they didn't take into account is that the AMD hardware supports both. What they came up with in... Let's go to one of these, right? AMD, right? What they came up with in 1.2, they're like, right, I got it. Subgroups, they're a thing. Was that right, or 1.1? Right, I got my thing wrong. They were like, all you need is a subgroup size. 64, right? Ought to be good enough. Well, AMD supports 32 and 64. So they had to change it. So in 1.3, they added min and max. And it's assumed that... wait. And then I think there's a list of supported ones somewhere. Wait, I got this. Yeah, so I've got it here where I check it in the properties. And then I try and set it up, I think. Oh yeah, then when you compile your shader, you pass in how many, the subgroup size you want. So yeah, they support a min-max now. But really they should have really supported a list, not gonna lie. Because I don't know what it means if you say subgroup size 33. Min and max seems a bit weird, but I'm sure it must be a power of 2, maybe. Yep. That's all it is. But yeah, I won't worry about it. I know you got that wave size thing for you, but I guess for you and your compiler, you just default to wave 32 and just have an option for people to say, hey, wave 64 if they want. Because things could change in the future. Yeah. That's great, man. I'm glad we found a solution for you there. That's really cool. No worries, my friend. Um, right, so this is the entity generator. What we have is just a structure which holds like, hey, this is a property, here's its string for the data type, here's its string for the identifier and some other bits. Here's like the archetype, its identifier, this is it in like a lowercase, and here's all the properties that the archetype has. And then we just basically have this code generator strut which has an array of properties and an array of archetypes. So and we also have these fields for like context-aware formatting as well, which is quite nice, and just a bunch of helpful functions here. And there's also like this turns something into snake case. This one prints a section header for comments in a file, and this is that context-aware printing, which is dead handy. So we just scan over a string, a format string, look for this symbol, and then if it's a capital A, it's an archetype uppercase. Lowercase a is archetype, lowercase a, and P is for property, like the identifier of property, and D is the data type for the property. So it makes it so we can, when we code gen, things are just really nice and easy to write out. So yeah, we just have a main function. The first part of it is just literally use the text reader and extract out. Just read over and extract out the properties. If there's the word prop, then just parse that line, right? And then if the line starts with archetype, then parse that line. Now, as I was writing it was a bit fiddly, using like a text reader where we just sort of like, go advance by each character and, maybe skip white space. So realistically, I should have just written like Alexa, like in a proper compiler, right? You'd Alexa into tokens and then just go over the tokens, and then white space is basically not there. It's a bit of a weird thing to handle sometimes in a text reader. You have to randomly drop these lines like, skip white space. But yeah, so after we've parsed that file, we simply just do all the code generating. So we got two files, remember, we got that sort of entity generated.h. I think I do a debug print here before I just print out the file again just to make sure everything was read correctly, so I can just debug that. But yeah, we first make the entity header file, and this is basically what it looks like. We generate all the properties as an enum, and we generate the archetypes as an enum. And let me show you an example of this format thing. So here is when we generate all the entity references. So we go over all the archetypes. We set this sort of format archetype to the one in that array. And this is the format string. So it's just a type def, but notice we've got these sort of like special format things here. And I'll just insert an archetype thing right in there. And we just call our lovely print format, and off we go. So, why do I keep saying so's? So the rest of the file down below is basically just more of this, right? For loops and print formatting and stuff. So I'm just going to show you the main concepts with what we're actually generating and how I designed it. So if we just keep scrolling, it's just basically the same thing, right? Just for loops and print formats and that into the header file and the source file. So one more time. So we just keep scrolling down. It's basically just more of this like print format stuff in a bunch of loops, and we're just code generating for every archetype or every property. But it's just a little bit weird seeing it in this string format. So I'm going to show you how I designed it and all the different concepts from that design. phase. So at the top of the entity file, or the entity code generator file, I basically just if-def to section out, and I just wrote down like a list of things I wanted to achieve. I wanted to achieve iterating over a bunch of properties in an area. I wanted to create a bunch of, I wanted to sort of the entity creation code, taking an ID, turning it into a reference. I wanted to have some kinds of typed IDs for the different archetypes, and maybe support swizzling, like investigate that. And I basically just sort of, hand wrote out some test code like, I want a property enum, I want an archetype enum, this is what my typed references will look like, this is what my pools will look like, and sort of design the prototypes of functions like I want to have a way from an entity reference to access a coordinate or another property, like I get in a set function at least. So an entity reference is a typeless reference directly to an entity in a pool. But this only has a valid lifetime of 1 frame because it directly points to an element within a pool. But we have an entity ID, which lasts for the lifetime of the object. And this is because when you delete an entity within a region or move an entity to a new region, the entity reference will change, but the entity ID will not. So yeah, I just designed some APIs and just really thought things through as much as I could. And sometimes I'll write out some implementation stuff, like how am I going to get this coordinate array from an archetype? But some things really needed proper implementation, like here's the iterator API. This is basically, it does look a little bit complicated, but I wanted to make sure that it supports doing SIMD as well in the future. So we will just be copying and pasting previous iterators and all sorts. But this iterator supports like filtering based on whether a property exists or not, filtering which archetypes you want to look over, and filtering which properties you do not want to exist. Filtering based on the region, right? I didn't really do this one in the end with a radius, but yeah, you say like, which regions do you want to start at? Which regions do you want to end at in the iteration process? And then we have a way of actually performing the iteration. So we can let it iterate over all the archetype pools first. So each archetype has all of its properties allocated in a contiguous array. So we iterate over the array of archetypes first, and then the next range basically goes through the different regions that we saw earlier, and it will just get you a start and end index into the archetype pools. And then you can basically just get the arrays from the archetype pools and simply just iterate over the properties that you want contiguously, and they should be in cache or in a lot more cache efficient way than storing them in a array of structures way. What else did I want to talk about? So that was just a bit of a high level overview on it really. So I should really dive into a little bit more specifics now, probably. It was a bit all over the place though, not gonna lie. So we could go through the code generator stuff, I think. Yeah, maybe we should go into the specifics. So let's go into the header files quick. Yeah, let's do that. Why are you writing C instead of C++? Yes, as Fossilbot says, when you see, you will see, my friend. C is a lot more of a simple language. I don't think there is a single feature from C++ that, maybe there's one, but it's questionable when you add it, like templates, right? When you add templates to a language, I feel like you want to use templates for everything. I feel like maybe besides that feature, right? Every feature that's in C++, like, it feels like it fixes problems, but it just adds more problems than it's worth. And C is a smaller language, and really like I think when they added like constructors into C++, maybe it was the first thing they added, I don't know, but it feels like they've always been able, every feature is to kind of help fix constructors or make things better, but really constructors just create such a big problem in C++. Because all these rules you have to follow, and so many silly things. So C just has less of that. C is not a perfect language, but it does a lot of things right, and it also has extra things that C++ does not have, like array initializers, where you can say like, oh, it's just the best, man. Array designated initializers. These things are like the bee's knees. Hang on a minute. Ignore that code. Unsee that code. I don't even know where it is. Wherever I use these things everywhere, right? Internet. Let's go. Designated C99. See, back in 99. Wait. No extension. It's part of the language. But yeah, so in C, right, when you do array initializers, there's some extra magic sauce available to you where you can say, hey, initialize 4, the element 4, and then the element 0, and it'll just do it contiguously after that. So the thing that's like great about this is if you have an enum, you can generate lookup tables that are stable even when you change the enum around. So there's lots of good stuff like this. There's also like structure initializers as well, which are just way better. Like you can name things. Like, it's just legit. And then you can mix it with array initializers as well. It's just amazing. So you can do the structure initializers like this. They could be out of order, which they're not like that in C++. They have to be in order in C++20. And you can also put arrays on them as well, which you can't do in C++. You can do array initializers. All sorts of goodness. Amazing. When you see, you will see. Hey, Davros, welcome, sir. Yeah. Yeah, slices could be alright, could be cool. Maybe. But sometimes it's nice if they're just separate when, yeah. But I do get it, right? You can return a slice, stuff like that. And having like the syntax is kind of cool. How do you handle operator overloading in vector maths? I basically don't. I just have a bunch of functions. It's got pros and cons. It might be a little bit harder to read, things are not as condensed, but then they kind of end up being easier to read in different ways because you're able to tell the exact sort of like operations and things. So like basically I create monstrosities like this where I go add, and it's just functions, right? And I have a suffix which tell me it's a float 32 times 3, so it's a vector 3. But realistically I should put that into extra lines and different temporary variables that are probably named. But this was a port of some other code really, so it's not really a good example. But yeah, I just have functions basically. So it's got the pros of knowing what the types are when you're doing the maths, because what's hard about operator overloading is you get a vector times a scalar. But you don't know that until you read the data type, right? And then sod's law, someone has stuck auto in there or let because they're Rustician or whatever they're called. And then like all hope is lost. You know what I mean? So yeah, functions. Oh yeah, the Vulkan crate infos are really handy for that. Yeah, I've used them all over the place there. Yeah, the bee's knees. Best viewers. That's a new thing I need to burn. I heard they've added different kind of move semantics now called relocation. Really? Relocation types. Sounds bananas. I see all the time, but I never had a chance to ask. What exactly do you aim for your engine? Fun, learning, education, um, uh, something relatively simple, fun, fun to work in. Getting something kind of distinct, unique-ish, right? These with like little ellipsoids and things. I'm still got to add texturing support, still got to do a second pass on rendering. But yeah, just something unique, something different, something with flavor. That's what I want. Bit of flavor, bit of spice, bit of Shazam. I also like to have a named multiplayer ad. Yeah, mad. Good old mad. I need to add that one actually. I don't think, actually maybe I have a mad. I think I do. I don't know a lot about C, but I hear people say that pointer provenance tracking is easier when the slice types. I'm not sure. Yeah, I think like I'm not sure exactly what that means, but maybe it means like knowing the difference between an array and a pointer is sometimes useful. I don't know. Like people in C++, they use a reference type because the reference tells them it is a pointer to a single object, right? But when I'm programming in C, so I don't even need to bother knowing about that because I don't have pointers to arrays typically. Or if I do, it's pluralized, right? Um, I don't really have many pointers to objects or yeah, so it's not really a big deal for me. Like, just read the code, have a look. Um, but yeah, there is that restrict stuff, right? That's another thing C's not good at. But I'm not sure if slice type is help with that. And actually named multiply add is good for allowing fuse multiply add with defined rounding assumptions. Yeah, that's cool. Well, I'm glad someone else has that opinion. Like I get it. Like some people like maths, math symbols, but yeah. To know if a point arithmetic is valid or something. Huh. Yeah, that just sounds like a load of bananas. I forgot. I remember hearing about that problem, and it confused me. And then I did kind of I think you brought it up to me in the past very much. I think it was you brought it up actually. Yeah. Right. Let's have a gander where we're looking at now. So I want to talk about maybe that code generate. Yeah. So this is that entity.h file. This is the non-code generated file. So this has got all those shared concepts in which don't need to be code generated, but the implementations of the functions that might be in here may be code generated, but it's just so I don't have to put it in string form. It's just in code form, right? Just it's already in a text file. So we've got this properties section here. This, we define a property as a byte for now, but if we go over 256, we should probably change that. But the enum is actually generated in the header file, and we have these like property exists and property not exists, where we set the high bit. So maybe we only have up to 128 really. I've got some asserts in for this somewhere, but this is for that iterator, right? So we can do that. We can say a property exists or property does not exist, and that's how we do it. We've got some archetype things, so these archetype flags. That's again for the iterator. So we only support up to, I think we only support 4 archetypes for now, but we can go up to 16 if we want, or even higher. I've just put a restriction on 4 because I don't want to add too many archetypes that I don't need, right? I want to see when I've hit that. But yeah, we can check if an archetype has a property. We can get that coordinate array from an archetype, because every archetype has a coordinate, but it's only as read-only. You cannot write to a coordinate as a special system for that. Here's that entity reference thing that I was talking about. This directly reference an entity and becomes invalid between frames. It stores the archetype in the high bits, and it stores the offset into the archetype pools, the structure of array pools, for that entity reference, or the entity that it's referencing. Then we can check if a property exists. We can deinitialize the entity in a deferred manner. So we don't want to have the problem where like we destroy or deinitialize an entity in a for loop, like an iterator, and then like that will kind of be different every frame. That logic will not really be consistent. So the way we solve that problem is we just delete that entity. So we put it on an array, and that means it will always be in the for loops that come after. And we can simply just at the start of the next frame, when we say entity system frame start, we just go over that list of deferred delete entities, and we just delete them all at the end. We also have the same problem for like setting a coordinate. That's done in a deferred manner, because you can like move between regions, those regions that we saw earlier, right? And when you move between a region, that region could be full because we have a certain capacity for the number of entities that can live in a region. So the way we get around that problem for now is we have a sort of deferred setup, or there could also already be an entity that's in that tile location. But I think in future we could maybe get rid of this. I just wanted to make sure that it was there was some implementation, but I may change it and make it not deferred. And then we have an entity identifier. So this one just lives for the lifetime of the entity. Each of these references in that 32 bits, rather just 4 bytes. And this one stores an index to the record in the record pool, and the record pool literally just holds the entity reference in there. So it's one level of indirection. And for an entity identifier, you're going to have these when you want to perform random access on your entities. So you want to, another entity references another one. That's random access. You're not going to have a contiguous access for a bunch of entities, i.e. Whereas with the entity reference, you get one of these when you use the iterator, or when you're using the region 3D grid lookup table, which you'll see more a bit later. So I don't mind paying a little bit of extra cost for the random access because it is going to be slow anyway. But yeah, these just have a way to get entity reference from an ID, or you can go the other way around where you get an ID from a reference. And you can also use that 3D lookup table thing that I just mentioned, and you can take a 3D coordinate and just get a reference back for it. And this can be null, right? Each of these IDs and these references, a zero value is null. And I did forget to mention that the entity ID has a counter in it. So if I were to deinit the entity and then reinitialize an entity and get back the same index in the record pool that stores the reference, we basically up the counter so that we can compare the counters. And if we try and use an old ID, we can detect that we have a use after free. It's a very handy technique, which we'll probably see a bit later on. So this is our pool header. Every one of our archetype pools has the same header. It has a bit set for all the properties. So this is just like that property enum that gets code generated. Each bit of that property, each one of those enum values has a bit in this bit set. So we can just, when we do like the iterators and stuff, we can just check this properties bit set and just see if this archetype supports these properties and skip this pool or not, based on the filtering requirements of the iterator when it's initialized. It's got a record IDs array, so every single entity, you can take an entity reference and then get an entity ID back, so you can go the other way around. This is useful when you move things between pools, and is actually how this function is implemented here. It just looks up into this array. And then we can find out for every region. So you index with the region index. So you flatten it into a 1D index from a 3D one, and you can get back how many entities are in that region. There's a next frame one as well, because when we add entities to the archetype pools, these guys, we reset that one. There's also a region entity counts for the next frame, because when we create entities, which you'll see in a bit, they're actually created in a deferred manner. Because if we create an entity in a for loop, we could end up accidentally like iterating over that entity within the for loop sometimes, and maybe not other times, and it's just very weird doing it mid-frame. So we commit it at the end of the frame. So we basically still put it in the pool, right? But we don't like change the region count, which is what the iterators use. Instead, of the beginning of the next frame, we just commit. We just copy these counts over to these counts here. And this array of coordinates is just the coordinate property, right? For every archetype has it. So you take that, the index field of the ent ref, and that can index and grab the coordinate out of this archetype. Do I want to talk about the iterator much? Let's talk about it. Boom, let's bring this guy back. So this is the iterator API. We'll see how it works in just a second. So effectively, this is a range of entities. So this is the iterator API here. So this is the iterator API here, which you saw earlier. I'll give a bit more of an idea how it works with a diagram in a second. But this is the range of entities that you get back. It has the archetype in there, a start index into the properties for that entity and a count. And we can obviously get the archetype back. We can get a reference back. So this is that iterator API that we saw earlier. It basically has this ent range structure where it just packs in like the archetype, the start index, and the count. Because when you're within a region, all of the entities are stored like one after the other, right? It's stored contiguously. So we return this ent range when you say, give me the next range for this archetype, right? So yeah, we currently just support doing a min-max area using the min-max world space coordinates. And then we do also support going over regions as well. The idea was to support different collision shapes and things, but that just got a little bit more complicated than it needed to be, so I just ripped that out for now. So yeah, we just store the start and the end regions, and this is the current region we're iterating, this is the current archetype we're iterating over, and there's the filter for the archetype, and here's the filters for the properties, right? Do they exist and do they not exist? So if we go over to this board here, each one of these grid cells is a region, right? This one has like 4 entities in it. Imagine if we have an iterator which goes over this space here, right? It will start on the first archetype, which, if you remember in that file, we had the organisms and blocks. So it will look for organisms. It will check, are there any organisms in the organism pool for this region? No. So it goes to the next one. Are there any organisms in here? Nope. Are there any organisms in here? Yes. So then it will go into the for loop, and then you ask, can I have the range for this region? And then it returns the range, and then you can basically iterate over the range of entities, and you only have one. Very poor example, you meant to have multiple, but the world is quite small here, which this system is not designed for a very small world. It's designed for a much bigger world with a bunch of entities within the same region. And then it goes over to this next region, and then it will say, hey, there's 2 organisms here, and it will iterate over those 2 there. And then it will repeat it again for the block archetype, right? You'll look at the block archetype and realize this thing supports the filters that we are looking for, and it will repeat the same logic again, right? Check here, no, check here, no, check here, no, check here, yes. And it will iterate over this one here. Right, so that's the iterator. I could talk about the memory system API. Yeah, it is kind of like a database in a way. Some people do view like this sort of entity component thing as a database, right? It's like an in-memory database. It's kind of like that, but it's for like this version specifically is for faster lookups, because I'm going to be having a whole bunch of entities being simulated, so I don't want this to be the bottleneck of the system. Because a lot of entities are going to be querying the entities around them. So yeah. Also, we have like mini tables, right? Contiguous regions that have, regions that have contiguous entities. Whereas in that sort of SQL database analogy, it doesn't quite map to this. But yeah, it's kind of similar. There's a query API in a sense. Excuse me. So this is this entity system like API. There's only two functions: a way to initialize it and a way to start the next frame, and that'll do all the deferred stuff in there. So we pass in a custom allocator. We pass in the number of entities we want at most, and then we pass in like how big a region is and how many regions that we fit in the world. And then we also have all the entity capacities for all the archetypes within a region. And we basically fix allocate everything. So with this information, we can fix allocate all of our archetype pools, which you'll see in a bit. And we allocate the record pools and some other pieces of memory as well. Right, so let's go into the entity generate file. So this is the entity code generated header file. This one you do not edit. I should probably add a very big warning at the top of this file to say do not edit this. But it is kind of apparent in the name as well, it's generated, right? So when we change that lovely layout file that we saw here, see it's just a few lines, but it makes all of these lines and more, which you're about to see, right? But yeah, it's not really like a good metric, right? Hey, my code generator takes in like one line, it makes 10,000 lines. We want to generate the lines of code that we want and not a bunch of lines that we do not need. So there is definitely a trade-off there, right? Because the more lines of code you have, the more the longer it takes to compile, and the more stuff you have to filter through to find the things you want. So yeah, we have to strike a balance there. But yeah, so here's the enums, all those properties get a nice enum. And we've done it with like this lowercase here so we can wrap it in that macro that we saw earlier here, where we can just like paste like the name of it on the end and it will just concatenate it, and so I don't have to keep typing out the prefix for the enum in cases like this. But that's the only place we really use it, I think. Let's get back to that file. Wrong one. Spoilers. And then we do the same thing for the archetype as well. Very similar thing, right? We've got an organism and a block for now. And then we've got these lovely typed references. These guys are pretty cool because they give you a way of like accessing properties a bit quicker, because with an untyped reference, if you try and access a property with like a get method, when it's outside of the iterator, shall we say, we have to do a little bit of logic before to figure out the offset to get the pointer of to the array, which you'll see in a bit. Maybe I'll retake that one. Then down here we've got these types references. So these are pretty great because they have strong typing. So you might have code which would just benefit from having a strongly typed reference or a strongly typed ID. We have those a little bit further down here. But the things they offer over an untyped one, other than them being typed, is that some of the functions which say, hey, can I get a property for this thing? Like, can I get a strength property? Can I get the health property with this reference, it's a tiny bit quicker if you have a types reference, because there's a little bit of logic that we need to do to offset and get the array, like the property array, has to be done programmatically with an untyped reference. Whereas if it's a typed one, the offset is just known right away, which you'll see it more in a little bit. But yeah, again, these ones are become invalid between frames if not you got the IDs, right? And these IDs are just more typed IDs of the untyped versions. And the untyped ones offer a benefit of basically having like a void pointer, right? You don't have to know the type, but it has type information, so it can get the properties that you want, or you can check if a property does exist and just grab it, type of thing. So it's quite flexible, the untyped one, but the typed ones offer a bit more rigor and a little bit more performance, I guess. So we just have the standard conversion functions to go from an ID to a reference, and the other way around, as we saw earlier. And then we have the archetypes as a structure where all the properties just go in there. And the only reason why we have this at the moment is because our creation API, when you create an entity, uses these. But in the future, we want to maybe have an array of structures version, so we can do some nice performance testing over this SOA version that we do right now. More on that later. Hey Kappa, how's it going? Right, so here's those archetype pools that get code generated. So, the organism pool here, right, as you can tell, it's got the header, right? The header that we saw earlier, which had like the property bit set and the number of entities per region, and the number of the coordinate property array. And then it's also got these extra properties which are defined in that file. Oh, excuse me. So these properties are arrays, right? And use that entity reference, use the index from the entity reference just to index and get the organism that you want. Yeah, I should probably go over like this thing here, and I'll stitch it in at the right place in the video. It was mentioned in the previous devlog though, but I'll do it anyway. But yeah, and you'll notice that the block archetype just has the model ID, it doesn't have any more properties. But again, these things are just, it's just an array of properties. And we have this union type where we have all of our different archetypes go in here. So we have the header. So we just want to access like the sort of common fields between all of these pools. We can do that. It's very useful actually. So we don't have to code generate tons of code. We can just look into that header and just write a lot of code without code generation, which you'll see later. And then the two organisms and the block go in here. So this is how we... So we also have this archetype pool union. This is just useful so we can access the pool header. So we don't have to generate tons of code. We can have a lot of like code in the entity.c file, and it just implements stuff in an untyped way where needed, and then we just call into some typed functions when necessary. But also this union helps us access the pools. It does add a bit of unnecessary padding, unfortunately, but you'll see that in a bit. So here's the entity initialization functions. We just take a pointer to the thing we're trying with the fields that we... So here is the entity initialization functions. They're deferred, so they actually get committed when you do that frame start that we saw earlier. And it returns a typed ID, and it takes a pointer to that data structure which has all the fields that you want to initialize the entity with. I typically don't like doing stuff this way. I typically like getting a pointer and setting my fields manually. But the problem is we're doing structure of arrays, and we have a variable number of properties, right? And it just gets a bit fiddly. And this is just the easier API to use. So, I think I'll just live with writing the data on the stack and then having these functions manually copy it in. So I've got a bunch of untyped. These are a bunch of untyped get and sets for every property. If your reference is an archetype that doesn't have this property, it's going to assert. But yeah, just as a way to get and set properties and things. You can check with that other function we saw earlier if the property does exist, if you don't know for sure. And then also, these are the typed versions of the gets and sets. So for instance, organism supports the model strength and health, whereas the block only supports the model ID. So it only has that function, right? And these are the slightly more optimized ones. And then finally, we have the ways to get the property arrays, which is kind of nice. So for an archetype, you can fetch the property arrays. And this is primarily used when you use the iterator syntax. So you can basically just, did I say iterator syntax? This ain't a programming language. And then finally, we have the archetype property arrays. So this is primarily used when we want to iterate over the entities using the iterator API. So this just, it takes in an archetype enum, that code-generated enum that we saw, and it just gives you a pointer to the array of that property that you can manually reference with the entity index. So this helps us facilitate doing SIMD operations in the future because we have direct access to this linear array of data. All right. So I guess we can go into the generalized C side of things. I don't really want to show every implementation about it though, do I? I really just want to point out some key things, Wait. I still want to show some data. Yeah, where's some... Right. This one. So this is what the entity system looks like internally. This is in the entity.c file. So we have this movement request. So when you move, we take note of the entity reference and the coordinate. Hang on a minute. We use entity references. That's bad. Two seconds. Let me fix this. Found a problem. When we do a frame begin, we can't delete entities because that will move things around. And the move will move things around. Bum, bum, bum. So the move request actually has to use an entity ID because that is fixed. Crying out loud. Right, let's fix that quick. That's not good. Do I have a way to set this manually with like an ID? Right, so yeah, maybe we'll use an ID. It's the preferred way of doing it, isn't it? Well, this is another good reason why you talk about stuff you've done or write comments, just so you can find problems in your own code. Happens all the time for me. Yeah, then after storing the ID, let's go to the move requests. So what do we do? What does the old ref want to do? Yeah, so we just ent ref it. How was that? Whoop. Ent ref from ID. Right, that ought to do it. Vaganda. New ref equal old ref. New ref. Right, that's pretty alright. Let's give that a go. Oh. Yeah, maybe we'll change that syntax later on. All right. 2, 4, 8. Oh, main.c. All right, should still work. Yeah, so that would have been a problem for if we moved entities and deleted entities on the same frame in the same region or something. Yeah, stuff like that would have bugged it up. Yeah, it's a C language, my friend. Hey, Martin. How you doing? Alright, so I'm glad we fixed that problem. Let's get back to the recap. So this is the entity system data structure internally. It's in the entity.c file, so the non-code generated source code. And what we do is we have this movement request strut that we have a nice array of, and when you defer move something, it will add to this movement request thing. We have the array of archetype pools here, so we can use the enumeration to get our archetype pool no matter what archetype it is, which makes it really easy to get the offset to the archetype. Basically, it's just a, it's a fixed step based on the enum, so it's kind of nice. And there's this record pool thing, which we'll talk more in a little bit. And we have like the metadata about the world, like how many entities per region for each archetype, and how big the regions are, how many regions we have in 3D. And we also have this lookup table, which allows us to query an entity at a specific coordinate and get back an entity reference, which can be null. And every time we delete and move entities around, this region cells 3D grid is maintained such that the references always point to the right places, even when things get shuffled around. Let's go to that region pool thing. Before I carry on, I do want to do the SOA thing, isn't it? Yeah, I wanted to talk about this. I need to bring this back in the video somewhere. So let's give a brief recap of how the properties are actually stored for the entities. So we went with the structure of arrays design. Maybe in the future we'll do code generation of a array of structures design, just to do some benchmarking. But effectively, it's the same as in the previous video, where we have, each archetype. Say if you have a bunch of coordinates for a particular archetype, we allocate one big array for all those coordinates that are contiguous in memory, kind of. So where they are contiguous is within a region. So imagine if all of these entities are the same archetype, these will all be contiguous in memory, one after the other. So you can think of it as something like this. Each region, so this is a region 000, region 001, region 010, and this is for the knight's archetype with the coordinate property. So, the knight's going to have more properties with more of these arrays, which use the same indices to get the different properties, right? So this region has 3 entities. All the coordinates sit contiguous in memory. And this region has 2 entities and they all sit contiguous in memory. This one has 4 and they all sit contiguous in memory. So this is where we've got to be careful, right? Our archetypes should ideally have, enough entities in every region. If we want to sort of leverage the fact that the data sits contiguously, right? Because if every region is just going to have one entity in there, then we're not really going to benefit from this SOA design. It's actually going to be slower. So we should really have at least, there is some number which I have to find. So there's solutions where you basically combine the archetypes into a single archetype and have optional fields, or you just make a larger region where it will encompass more entities. But that comes at a trade-off of you'll be iterating over stuff you clearly won't be near. So yeah, you need to have a balance there. Right, so now I'll go back in time somewhere in the video, which would be cool. I'll just draw a video, a diagram of this. Have I got it somewhere already? No. Draw another array. Bum bum bum. Right, so let's talk about how we take an entity ID and turn it into an entity reference. Basically, we have this thing called like a record pool, and each record, it just holds a reference in it. That's all it does. So we just take that entity ID, we take the index bits, we realize, oh, well, our ID is at index 3, and we simply just, take the reference out. So there's that layer of indirection, right? But what we also store in this array here is, well, I think we store a separate contiguous array actually, which uses the same indices, but instead we store like the generation counter and if the element is free or not. So in here we store like a number where we know every time we free this slot, because you can have free slots in a pool, right? These are free slots, whereas these are taken. Every time you go and free it, we will up the counter in here by 1, and the next time we make an ID with this slot here, it will have a different counter, so we can track use after freeze. Do I want to show any of this? Probably not, it's just code, right? I could talk about the free and allocation strategy, maybe. So how we like allocate new slots in this pool is we simply just like, we check if this one is free. Is it free? Sorry, no. Do I want to do this? Maybe not. People can figure out pools elsewhere. There's many more things about this system that I want to talk about. You just explain how a computer works, talk about sand and stuff. Yeah, all that undefined behavior stuff just gets kind of crazy. Like a lot of the time it just falls down under like, how does it actually work on hardware? But yeah, then compiler people start like abusing the undefined behavior. It gets problematic. But I find the undefined behavior a lot worse in a lot worse in C++. Pretty crazy. All right, where's the where do I want to what stuff do I want to show off? Like what is worth showing? Right, there is the generated source file. What is worth showing? Does that assert? Yeah, it does assert, doesn't it? Right, so here's what I was talking about with these like untyped references, how they are a bit slower. So they will use this sort of like archetype model ID array thing, um, which is used for the iterators, and it has a bit of magic which goes on, right, which we'll get into just a second. But the typed gets and sets, these literally just go into the entity system. Like we know it's an organism type, so we go into the archetype pool, offset based on the organism enum, and then just get the pointer directly. So it's basically just like, you know, it calculates an offset from the base pointer of this global variable, and then dereferences it and gets this one, and then off it goes. Gotta remember how this works again. Yeah, so it gets the lower bits. Yeah, right. How this code basically works is if you remember back in that layout file, you got these properties, right? They're in this specific order, model ID, strength, and health. So when an archetype has these properties, you can put them in any order here, but when we code generate it, we sort it such that it's always in the same order. And this is the order that the property enum is generated in. So given that assumption, we can do a bit of magic where we check the property bit set. We use we get a bit set or a bit mask where we have all of the lower bits, which include the what is it doing again? Does it get the property bit set? And the lower bits, including this one. Including that one. Not really beneficial. Oh yeah, not including that one. That's right, isn't it? Yep. I forgot where I got up to now. Oh yeah, the assumption is I'll just retake it maybe. Right, so how these functions work is if you remember back in the layout file, we declare these like properties in this order, and you reference them to the archetype, which one it uses. These can be put in any order, but internally in the code generator, we sort it such that they remain in this order. But they can obviously have, every archetype doesn't have to use every property. They can have some missing, right? But as long as they're in this order, it's all good. So based on that assumption, we can make code like this. So let's take the strength one as an example because it's not got a property ID of 0 or something. What it does is it looks at that property bit set which we saw earlier, which lives in the header of the pool, and it checks it, makes sure that it does exist, right? And then it will do one shift left of that, then take one, and that will generate a bit set for all of the properties which come before this one. And then we and the property bit set, and we've got the lower bits. and we simply just count the bits, and this tells us how many pointers, how many property pointers we have before this property, and we basically just skip over them by doing some pointer arithmetic. So we jump after the header with a +1, turn into a pointer to a pointer, and then we index the array of pointers with the property array index and get the array of strength properties and just return it that way. So this is why it can actually be a little bit slow, because it's a little bit more computation. It's just probably not that bad, but these are just probably like better, right? It's just one bit of arithmetic. Yeah. Right, so I don't know what else I really want to go into. I've got, we want to talk about, or I can just show the initialization code. First Helix user on Twitch, yeah. It's pretty alright, I like it. Yeah, it's pretty decent. I would recommend it over NeoVim if you're learning if you're coming from if you want to learn a modal editor. Comes set up out of the box quite nicely. You don't have to mess around with a config. Yeah, quite happy with it. There are a handful of things where it's like, why haven't they done this yet? But it's pretty good. Still kind of getting used to it, to be fair. Oh, for crying out loud, these buggers. I wonder if it ends up just banning, like, so people will get their accounts hacked, right? Maybe. So this is what the initialization code looks like. We just make an array of function pointers. So when we initialize the whole entity system, we just go over all these function pointers and initialize every archetype pool. So yeah, we just set up the bit set right, and then we just allocate these arrays with the custom allocator. So we never reallocate these or anything. But we'll just done at boot. I forgot to mention that this is all code-generated code. When did I say? I wonder if these references, isn't it? It's all explanatory. There's those copy functions and stuff. I think I'm nearly there. You know, I think I'm like not far off. Like I just want to entity.c maybe. There's maybe like the entity move or remove function. I could maybe show an example of. Yeah. Right, maybe I'll do that. So here's another example where like in the code generator, I've made very specific functions for different archetypes. So this moves, it literally just mem copies a single entity from one location to another one. So this can move it between regions, and it can also defrag a single region, where we can take an element from the end of the array and move it to the slot which gets deleted. So this moves the organism, and this moves a block, right? It just copies the coordinate property and then copies the model ID property. So with this function, we can obviously make some function pointers. in a nice array. And then inside the entity.c file, which is the non-code generated code, we can make something like a remove function, where this is just hand typed by me, whereas the other one was code generated. But I'm able to like basically remove an entity by taking the element from the end of the array and filling in the entity which is being removed. So I'm just going to the region, calculating the offset to the region, and then taking the counts down and basically saying if this is not the element at the end of the array in the regions, then copy the record IDs over and then just call that function pointer for that copy, and it'll just copy all the properties. So we're able to like, so I don't have to have this in some string code in the code generator. It could just be in the code file, and the stuff that can be code generated can just be smaller, basically. I think that's mostly it. I don't really have any other things about the entity system. Oh yeah, I want to talk about the things I've may have failed on. Yeah, it's for shaders, man. So yeah, it's a C shading compiler. So we use it for Vulkan, compiles to SPIV. It's got some limitations. There's no pointers and stuff, but works alright. It's pretty good. I can share structures and functions between CPU and GPU. And a mask library. It's got swizzling as well, because swizzling is kind of nice. But yeah, pixel shaders, vertex shaders, yeah, all sorts of goodies. It's pretty neat. So one of the things that we wanted to achieve with the code generator in the first place was have this unified API between structure of arrays and array of structures. We did actually mostly achieve that. The only thing that we fell short on was the iterator API. And as I mentioned earlier, the reason is I wanted to make sure that we could do SIMD stuff. So having a pointer to the array of coordinates and then just getting literally a contiguous array of entities really helps out doing some SIMD optimized code. So when we write the game logic and I want to do some speed comparisons between SOA and non-SOA data structure and see if it actually brings me any benefit or how much benefit it brings, right? Just to make sure it works as we intend it to. I will just have to write the iterator logic a bit differently and have if-defs around it. But it's not really that much of a big deal, I guess. Most of the code will stay the same except for this, so kind of happy with that. And I'll do it maybe earlier on, so I don't have to rewrite every system of the game, right? Just have an isolated set of things and have a good test case so the benchmarks are not lying. Right, what's next? Optional fields. So the other thing which we wanted to do is have maybe optional fields be kind of embedded in the entity system. It was kind of said that we might want to do it for archetypes, but might not. And I ended up kind of wanting them because it would have helped me standardize on a single on less archetypes within the system. So before I go and make a distinct archetype, I can just add another field on, which is kind of partly there only for these one or two entities, right, that could exist. And it will be slower because there'll be a bunch of empty slots, but then it wouldn't have a whole new archetype pool, which brings in a whole other load of problems. So the way I've decided to do that, because it would have been a lot more, it was a really fiddly to do it inside the entity system itself. Like you had to have different bit sets and checking more things in the system when you're iterating. It was just weird. So the way I've decided to do it is just every property, like imagine this weapon ID. Well, every property itself manages its own optionality, if you will. So if it needs to be optional, the property itself has a null value. And that's how we can do optionals for now, if we need them. But maybe we could build them back into the system if I feel like it makes sense. Hey, Dalsy, how's it going? How have you been? It's been a while. How you doing? Do you want to see some progress? Bum, 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 bum. It's an entity system which is very small. So we just got this is a world, very small world. It's like the size of my palm. Just moves an entity up and down, and it puts a box down. Well, there's a box that goes in the way sometimes. But yeah. And here's all my ellipsoids. It's making my GPU go crazy though. Yeah. It's pretty alright. So yeah, we're just building like some we're working on building like an editor now, basically. So I'm building on the game technology side. And then we'll get back to rendering after we can actually build objects, because I'm just making stuff out of a bunch of ellipsoids. So it's really going to need a bunch of custom tooling. But yeah, the family's going good. We had a bit of sad news the other day because we had was trying for another baby, and we had it passed away at 7 weeks, but we didn't know till like 11 weeks. So yeah, we was dealing with that last week, unfortunately. But other than that, things are going pretty great. The boy's good. It's pretty cool. You know, it makes me so happy just seeing him playing with his toys and stuff and just being silly. Yeah, it's really great. So my wife is good as well, other than obviously dealing with the sad news. But yeah, it's cool though. We'll try again, right? But yeah, try again and all that, you know. But it was just a lot of because my wife had been off ill and she was going through a lot of it was just a very tough time, and then to come out at the end of that tough time with like no results, it's just quite sad as well. On top of losing the baby, but it's cool. But yeah, trying again for another one. Should be good. But yeah. How about you? How's your family doing? Hope you're doing well. So I think I'm done with this system. Let me just do an outro, and then we'll talk about what we're doing in the next few streams. Let me just figure out how we do this again. It's quite a long one, but it was good. Sehr gut, as the Germans say. Still went back to school today, so we're back in chaos mode Monday to Friday. Oh yeah, the drop off. Yep, go to work, pick up. Alright. Alright it. Alright, let's recap that quick. Let's outro it. Right, that does it for the entity system. If you guys have any questions, you can feel free to join the Discord and ask away there, or drop some questions in the comments. So if you want to watch the VOD channel, it's day 151 to 159, where there's more answers in those videos too, where I actually develop it live. Twitch channel where you can tune in live and catch future streams. There is a timeline on Twitch there if you fancy that. And there's the VOD channel link, there's the Discord link. And thank you for everyone who supports me via Ko-Fi or Twitch. You guys get source code access and can download the code and play it on your machine. Thank you so much and see you in the next one. Bye-bye. Cool. Let's talk about what's the future. So tomorrow I've got a video to edit and that's long. But anyway. Game tech plan. Game tech plan. So we just done the entity system. I guess I can mark this off as being done. Ding. But we want to do decoding and encoding. So I guess I can talk about that for a little bit. So we're going to be having a few things, right? So let's I guess make a new file. We're going to open a file from docs encode plan. So encoding. What type of stuff do we want to encode? What files / data types do we want to encode? And the encoding system is not going to just be done for files, right? It's for networking too. It's basic, serialization, right? Can I take a data type and turn it to something that's something else that can be transported to the file system or over the network? So we're going to have, first of all, there's two serializers. How are we going to encode? Okay, the encode, what are the encode / decode targets? Formats. So basically, right, we want a text format for version control. Yeah, we can do diffs, right? Pretty nice. And then / development, right? And development. And then we want a binary format for release and networking. Because I am going to be doing some form of networking. Probably going to be peer-to-peer and quite simple. I imagine it might be lockstep, to be honest, because the game ain't fast. Yeah, so we're only going to have two formats. The text format might be JSON. I don't know. JSON 5 ain't bad, right? But yeah, also having a custom format is is all right. You know, I'm not fussed about chucking it through standardized tooling, so I don't think I need a JSON file. But I don't need it to be JSON. So yeah, what things do we need to encode? Well, levels, right? Like a level itself. A level is going to house entities, right, from the ECS system. Well, we don't call it ECS, right? From the entity system, right? All those archetypes and things. You've got we might want to. So if you create a level, no. So we also have like a model, like create a model, right? We saw that in the to-do list. So you've got like, I think there's two different formats for it, right? There was like yeah, we want to store like material data. That's one of them. So the editor stores a list of edits, so we can keep the undo and redo between sessions. That'd be pretty cool. And the game file format is a BVH tree. So the editor one is just going to be a list of edits. So this would just be the we want a material to be saved out. We want a list of edits, model edits. It's just an array of edit operations, like history, edit history, and then you also want to have a model BVH tree. So that's actually a tree. Store that to disk. We also want to support yeah, it might not be just a list. I don't know. Anyway, prefab editor. That's just basically like a level editor anyway. Same thing. Yeah. An organism editor. So this is like actually building some thing which sticks models together and skeletons and things. So we want like to encode like an organism with like a skeleton and things. Organism, skeleton. What else? It needs. So there's an organism template. That's a separate thing. And then an organism has. Right, defines connecting bone. Oh, right. Each defines connecting bone positions. Didn't that get replaced with something else? Oh no, yeah, so each organism has a set of bones, and then everything else added on top is procedural bones. Yeah. Right, I'm not sure why I'm revisiting this now, to be honest. Well, yeah, it's just an idea of what I'm going to be serializing, basically. How complicated does my system need to be? So, yeah, I think you have like an organism template. which declares AABB areas. It declares like connecting bone, define key bone positions for an animation. Not fixing move around by the model, awesome. Key bones. Yeah, skeleton key bones. So you define a humanoid, right? Shoulder pieces, chest piece, legs and everything. But then like if they want extra bones on top of that, it's all procedural. But you can have custom pieces and things. Right, so whereas the organism is going to have, you select the pieces and slot them together. Right, procedural bones. You got your pieces. I always forget you spell pieces. There we go. So you get your pieces and you fill them in. It will link to a template as well, right? Reference an organism template. Yeah, what else will we need to serialize? There's all animation stuff as well in the future. But yeah, maybe this is good enough. I don't think there's anything. Yeah, there is animations though. A timeline and things. So when you build like a model, it could also be like an organism piece or something like this. And yeah, would have to skin, like do weight painting maybe on the ellipsoid pieces or something. Or it might be automatic. The first version. But yeah, maybe this will do. So we've got an idea of basically what we want to serialize out. We've got these like, but yeah, there's also like animation. Let's just write animation in there. So yeah, there is kind of yeah. So levels and entities, these are mainly going to probably be for test levels. I might want to support some kind of like modding in that in the future. I don't know, but they're mainly just going to be test levels. Like I've got a small little world that I've thrown together, which allows me to, maybe I can run some tests or something and see if stuff breaks. I don't know. But it's also there just so I can quickly set up some things before proc gen. Maybe I'm testing like combat or something, or maybe I'm testing buying stuff in a shop or something like this. That's where a custom level makes sense, right? Material, obviously we have materials. Actually saving a model that we've made, and these things which make up like a player, like a skeleton of a player and an animation, right? So they are kind of quite complex, and the thing that we've got to be careful of is that we want to make sure that we don't bugger this up. So like if we have an old version of something, we want to make sure we can at least like update things properly. So we can't just do like yeah, I want to make sure we definitely like update these things properly because this is going to be the data for our game. And yeah, I have ways of doing that. What about level generation tooling? That comes later, I guess, like editors, like in the editor's lifetime. Good question. That is prefab editor. So basically, like a prefab and a level is basically the same thing. So yeah, you'll be able to put down. Yeah, maybe the tile editor is like the blocks and stuff. We only have one world map, so maybe a prefab won't have the world map or something. I don't know. I've got to think about it. Maybe they are different things. But yeah, maybe. But yeah, it's part of this section at least. Maybe it splits into two. When we get there, it might change actually. But yeah, we'll have like adding and removing like the blocks on the ground, painting a world down or placing players and stuff and rotating things. Yeah, so I don't think we're gonna. Yeah, so we'll probably have a way of like, imagine like Minecraft create mode, right? It's gonna probably be like that because the world is gonna be made up of these like blocks, but we're not gonna make them like Minecraft blocks, right? The world is just made up. It's just on a grid, right, as you would in a game. But they will not be blocky like Minecraft. They'll be like slopes and things, right? Bit more detail, but with ellipsoids. So yeah, we'll probably have a way of like painting down. So you get the mouse and you go and paint down a layer, a bit like you would in Minecraft, I guess. Well, Minecraft's done more of like moving a player around. But yeah, this would be more like placing down on a grid and yeah, just tooling like that really, and maybe having ways of doing a mass sort of area or something like this. Or maybe just starting a world from fresh and just saying, hey, I want like it to be this tall. Filled with these blocks or something. Or maybe start the proc gen there, I don't know. So yeah, tooling like that, having ways to delete. Um, um, so yeah, what do we want to achieve? What sort of what features do we want? Do we require? So the thing is that I would like. This is some notes I wrote down, right? Because the thing is, I've done it all in the past, right? And there's pros and cons to everything. I've done hard-coded stuff. I've done type information, right, where I make type information, and I just have a bunch of functions which operate on type information. But that just becomes like if you have a bug in your serializer, like your binary serializer or your text serializer, that's just a pain in the butt to debug because it's like you keep calling into the same functions many layers deep, and it's just a pain in the butt. But then I was thinking like there's not too many types, so maybe I can hard code it. But we've just written a code generator for the entities, and it does seem quite beneficial, right, having stuff being code gen. And also the entity system, we're probably going to code gen this stuff. Like, if we don't have a code generator for the decoding and encoding stuff, we'll be able to code generate the entity encode and decode functions, right? So I'm thinking we might as well just go all in on this another code generator for encoding and decoding, and it's going to bring a lot of benefits because we'll be able to still have the debugability of, by saying, hey, I'm decoding an entity type, put a breakpoint in the decode entity function, and we can just put a breakpoint right in there, and we can, it's not going to be in some generalized data type reflection of thing. It's going to be in hard-coded functions or hard, So I think what we would like to do is have, we would like to have hard-coded functions for each type and serializer. So specific functions so we can fully leverage the actual serializers and encoders. So this is like for improved debugging and fully leverage the encoder specifics. So like we have a binary encoder and a text encoder. The text encoder is good at, it wants the distinction between hexadecimal and displaying it in decimal. Whereas a binary encoder will want the specifics about packing bits down, right? So that's one thing that we want. We also want some level of like automation of some kind, right? This is where CodeGen seems like the only option, doesn't it, really, with these two requirements. We also want some kind of like stable, like, I want to be able to change things and I don't break my formats. So I think what we want to maybe achieve as well is like I want to somehow have some kind of stability when making changes to these data types. So what does this mean? Upgrade, the ability to upgrade, the ability to maybe say that we're making a breaking change, so not upgrading. We might do this at some point. Ability to make a breaking change and start over with no upgrade support. But that is really a last resort. We want a system, I think, because the problem with encoding systems and things. So yeah, I think we need versions upgrade, and we want like the ability, like with encoders and decoders and like versioning stuff, there's like a handful of rules. So I don't think I have time to go over the rules today. But for example, if you add or remove a field to a type, that you're serializing, it has implications. And I want to maybe not have to remember all these rules, right? Because it's really annoying because you have like 5 rules and you got to remember them all every time you make an edit. You might be going and, going off and doing something else and you go, crap, I need to, you're like really deep in some other code and you have to change one of these formats and you forget one of the rules and you've just gone and broke something, right? You might have created a new level in a broken state or something, so it breaks upgrading or something. I don't know. So we really got to be careful. So we want to have like a sort of like, I think I want to have a way to be notified when I've broken the rules, right? Notified when I have broken these sort of rules when editing a data type. Because I think that's quite yeah, it could be quite problematic. Or maybe we have a way where the rules are very simple. That's another solution we've got to think about, right? Or can we have a system where the rules are very simple Yeah, I'm not sure. We'll think about it. No, we always want to be notified in some way. So yeah, this is basically the things we'll be going over the next week or two of streams. So we'll work on like a plan of like how we're going to execute this, like how are we going to is there any more sort of features that are require, right? So hard-coded functions, automation, so we'll probably, probably code gen. So we'll probably need another custom format or whatever. Stable when making changes to data types. We can have versions, upgrades, notify if we break the rules when editing a data type, ability to make a break and change and start over again with no upgrade support. Yeah. Yeah, and I guess I can do another one, right? Built specifically to leverage. Oh no, I've already done that here. Fully leveraging encoder specifics. Yeah, it's good. It's good. Right. Yeah. So the next couple of weeks we'll probably be working on this system. I think I've got. What have I got? Yeah, I've got 3 streams down for it. That ain't gonna happen. It'll probably be more like 6 or more. It might be another 8 stream one. Yeah, so in the next stream we're gonna actually like plan out this code generator, think about all the problems, and answer all of these questions. Just design it all out, and then we'll make a start on it probably in the stream after that. So that'll be Sunday's stream, doing the plan, and then the next week we'll probably start implementing it all, and yeah, going from there really. Right. I got a jam. Here's the Discord link. If you're going to come and chat in the meantime. There's a YouTube channel, VOD channel. Thank you, Gloria. So good to see you. Good to see you. I hope you all have a good weekend. Start to your weekend. You know, it's probably good to get outside. It's becoming winter soon. Make the last of that sun. Rust. Go raid the Zig guy. This guy was making a kernel module a second ago, now he's making a debugger. Let's do it. It's pretty fun. You probably like inject interrupt instructions and things. And then copy the old code somewhere else. I remember reading about that. It's quite interesting. Right. Have a good weekend, guys.